So we're still in Unit 3, and Unit 3 is all about functions and relations. And one of the main pieces that I want you to take away from Unit 3 is how to read a graph. You see graphs all the time in the real world, whether it's looking at stock market values, looking at what's going on in the world around us. Sports uses graphs a lot. So graphs are one of those things that, stick out because it's a real quick picture that we can represent literally. And I want you to be able to read them correctly. So a couple of things that I want you to remember is when we look at a graph, we always label our x-axis and our y-axis. And so here's a picture of a graph, and we know it has something to do with time and height. So if I want you to describe this graph, so watch how I'm describing this graph. First it says it shows the height of a roller coaster during a single ride. Describe the roller coaster ride. So here we start. Here's my starting point right here. So if this is height, notice my starting point isn't at 0 feet. Roller coasters never really start at 0 feet. They're always up on something, whether, like at the Giant, you got to walk up all those stairs and, it levels off at maybe 15 feet is where it starts. So my starting point is not at 0. So the height is not exactly at 0 feet. It's a little bit above that. Now I want you to look at this line right here. What does that mean? It's saying that my height is staying the same as time goes on. And I want you to think about the Giant. When you go out of a roller coaster ride, it's pretty flat, right? Time's going on and my height's not moving. And then what happens? Real quick, because this is time in seconds, my height goes straight up. Now, to me, this graph isn't really realistic because you don't see roller coasters that just zoom straight up at the same rate that they zoom straight down. So I don't think this graph is a good picture of it. But notice what happens. Real quickly, the height goes to the top of the point. And then what happens? I get to the apex, and then the roller coaster goes down real quickly. Well, we've all been on roller coaster rides, and we know that they increase not at the same rate as they decrease. And so then what happens? We go up another roller coaster and we go down super fast here. And then it's going to level off for a little bit. And then it's going to go up. And then it's going to go back down. And then we return home. So how would I write that? We would say the roller coaster left the gate. And after a few seconds, it increased in height and then went down. It went straight back up and down again. The roller coaster traveled a bit before it went up and down another hill, then returned back to the gate. Okay. So I don't want you to watch this video and watch me write these words. So what I'm going to do is I'm going to show you the graph, and then in my words, I will tell you what I want you to write down. Okay? So let me erase this real quick. All right, so for this next one, it says sketch and graph the given scenario. Well, the first thing is I have a blank graph here, and I know that I have to label my x-axis and my y-axis. I want you to think of your x-axis as something that is your independent variable. It means independent variables, they don't change. They stay the same. This axis can stay the same. It can change up and down, and it depends on, this y-axis depends on what's going on with x. So we have our dependent variable, we have our independent variable for x, and our dependent variable for y. So that's really big words that we need to know. So let's look at number 2. It says, in a single day, it snowed lightly during the morning, then heavily for the rest of the day. I'm telling you what to do. Graph time on the x-axis and graph total snowfall amount snowfall amount on the y-axis. So if I look here, it says in a single day, it snowed lightly in the morning. So my 0 point, snow didn't fall. So I'm starting at my origin. No time happened, no snowfall. So what then happens? It snowed lightly. So as time went by during the morning, my snowfall was light. So as time increased, my snowfall grew a little bit more. And then it said, then heavily for the rest of the day. So I increased my snowfall amount for the rest of the day, and it looks like that. That's what my graph would look like. So increased, and then it really snowed heavily. So as time went on, my snowfall amount got more and more. Okay? Right, let's look at number 3. Mia bought a painting. The value of the painting dropped by 25% after 1 year. Then increased in value over the next 5 years, reaching a value that was twice what she paid for it. Graph time on the x-axis and value on the y. So remember what my origin means. It means the value is going to be 0 and time is going to be 0. Is my graph going to start here at the origin? No, it's not, because it says Mia bought a painting. She didn't buy it for 0, but we don't know how much she bought it for. So my graph, the values, I'm going to put somewhere here in the middle. That could be my value. I don't know what it is. This is just a rough sketch. So after 1 year, the painting dropped by 25%. That's half. I don't want to do half. So I'm just going to kind of estimate a drop. If this were a halfway mark, 25% would be between here. So it dropped in the first year, roughly 25%. And then it says after, and then it increased in value over the next 5 years, twice as much as when we started. So I want to go twice as much as when we started. So that's what my graph is going to look like. Okay? So it decreased, and then it increased in 5 years. 1 year is pretty short, so if I were to mark these, this is kind of what it looked like. After 1 year, it dropped by 25%, and then over the next 5 years, 1, 2, 3, 4, 5, it increased twice as much. All right, let's take a look at number 4. Again, here's my 0 point, and it says a basketball was dropped out of a window on the second floor of a school onto the concrete below. Each time the ball hit the ground, it bounced and reached a height that was half of the previous bounce. It continued doing this until it settled on the ground. Graph time on the x-axis and distance from the ground on the y. So here's distance. This is 0 distance. But did it start at 0? No, because it was dropped out of his second floor window. So here is going to be my starting point, and then it's going to drop, and then it went, each time the ball hit the ground, it bounced and reached a height that was half of the previous. So I'm going to go up again to half of the previous, and then it went down. And then it went half of the previous, and then down. And then it went half and down, and then half and down, and then half and down until it reached the ground. So that is what my graph is going to look like there. So as time went on, the distance, notice it wasn't a curve like this. Okay, it was just down, up, down, up. All right? And the best way to make sure you understand these is, unfortunately, is just to do more practice problems. So let's look at number 5. Number 5 says that Jace is speeding on the highway and gets stopped by a police officer. The officer gives him a ticket, and he continues on the highway. Graph time on the x-axis and speed on the y-axis. So he was speeding. So his starting point is right here. He was speeding, and he's going and going and going and going. He's at this fast rate. So time's moving on as he's going faster. And then he gets stopped by a police officer. So he gets stopped. Okay, so he's back at his acceleration is 0 because this is a speed. Speed is right here. So he gets stopped, and the officer gives him a ticket. So while he is stopped, the officer's talking to him. So time is still increasing as he's stopped, and then he continues on the highway probably at a slower pace than last time. Okay, and so then he would continue going down the highway. All right, so that's Jason, a speeding ticket. All right, so let's look at Carlos. Carlos is a running back on his football team. He ran the same number of yards in each of the first games of the season. After the 6th game, he did not play for the rest of the season due to an injury. Graph games on the x-axis. Why am I writing x-axis? We know that's the x-axis. Games on the x-axis. And total yards on the y-axis. So that's the first thing we do. We've got to, we have to label those. So it says, he ran the same number of yards in each of the first 6 games. So he started at 0 at the beginning of the season. His yardage increased. It increases steadily over 6 games. So it's game 1 went on, game 2 went on, game 3 went on, game 4 went on, and then he gets an injury. So he's not going up anymore. His yardage stays the same. So that's what my graph's going to look like. Games, total yards remains the same. All right. Now, it says, number 7, Alice drives a school bus. On her morning route, she stops at every block to let students on. Graph time on the x-axis and total distance the bus travels on the y-axis. So she's starting at 0. That's where she's going. Time goes on, and her distance increases, but she stops to pick on a kid. She's not picking on a kid. She's picking up a kid. She could be picking on. So time's going on, but her bus has stopped, so she's not getting any more distance. And then she goes a little bit more, stops to pick up the kid, goes a little bit more, stops to pick up the kid, goes a little bit more, and stops to pick up the kid. So that's what her graph is going to look like. All right. So hopefully you got some practice in there about reading a graph. So we can match these. This is kind of a fun one. So pause and see if you can match these. All right, let's look at Carrie. Which one of these graphs belongs to Carrie? So Carrie spent a small amount of money in the first half of the month, then spent the rest in the second half of the month. So she's spending a small amount in the first month, a lot the rest of the month. Luke steadily spent his money throughout the entire month. Mason rapidly spent all of his money in the first half of the month, and then he was done. So Carrie spent a small amount, and then she increased it in the second. So this is going to belong to Carrie. I spelled your name wrong, Carrie. Luke steadily spent his money the entire time. So that's Luke. And then Mason, he spent his money, and then he had no more. His dollars spent were gone. So that's Mason. All right. If you have questions, let me know. If not, good luck on your homework.